Hello, good morning. My name is Mohammad Rafi. I'm a student of Leeds Packard University and cybersecurity. My research topic was machine learning based phishing website detection using under the supervision of Cliff. So let's move to the agenda. In this presentation, I will give you an introduction of my topic, research gap, problem statement, and research objective, is proposed methodology, result, and lastly, I will go to the demo part. So phishing websites are the fraudulent site designed to trick user into revealing sensitive information such as username, password, and financial details. They often replicate a trust organization like bank, e-commerce platform, or government portal to appear legitimate. Phishing has become one of the most widespread and demanding form of cybercrime, causing sufficient financial and data loss globally. Attackers are very smart. They continuously evolving their techniques using zero-day tactics and redirection techniques to that make detection increasingly difficult. Traditional blacklist and rule-based systems struggle to keep pace with these evolving techniques. And this growing challenge has made phishing website detection a critical area of research in cybersecurity. These are the type of the phishing or fraudulent HTTPS phishing. Actually, in this website, we have a valid SSL certificate, so that is used on phishing websites posting, search engine phishing, clone phishing, pop-up phishing, social media phishing, and these are the type of the phishing. So let's move to the research gap. In the existing research, there is a limited feature. So only I used a data set in which we have only 55 features related to HTML websites. Lack of explainability that is not show that which feature is most impact on these target variables, weakness against involving attacks. As I told you, these system are the role-based anti-interaction technique that is more easiest way to attacker to hack this system. A real-time application gap and imbalanced data in existing data set. There is, I show the data set detail in the next slide, but the classes between legitimate and phishing web the code is not completely balanced. So there is some gap. So I use the balancing technique to balance the data. My problem statement was involving phishing attack. Uh, uh, I can suggest a solution that can use the advanced website features like CORS, CRSF token, this phishing technique, these new features of website involved in it. Uh, Existing and also use a sharp technique, shape technique to explain the impactful feature that is involved in involved in phishing attacks. So I will also explain the feature, which feature is most uh, impactful in the phishing website detection. My research objective are the first objective is I extend the data set. I use both technique, machine learning technique and deep learning hybrid model to detect the phishing website technique. Also increase the evolution matrix performance accuracy recalls this evolution value. I will increase these things. Also use explainability shape for the transparency to show that which feature have most impactful and which feature is not impactful in detection of the phishing website. This is my proposed methodology. First of all, I will collect the data and extend using Selenium Beautiful Soap. After that, I will pre-process cleaning and scaling the data. You develop a machine learning and hybrid deep learning model, integrate the shape technique with the hybrid model, and also, then I will train a model and will show you accuracy, precision, and recall and confusion metrics of my model. So data collection, existing data set have 235,795 website record, in which 1,945 are phishing and 1,34,850 are legitimate. Extending fit, I will extend a feature from existing data set from 55 to 83. So in which I involve the security header, JavaScript behavior, and HTML attributes. I use the automated script to extract a feature from these existing dataset web URL using Selenium, Beautiful Soup, and WebDriver technique. And I will clean and prepare that dataset that is used for the model training. So in model development, I divide in this part into two parts. One is the machine learning model and another one is deep learning model. In machine learning model, I show the process that is cleaning a data and encoding a categorical data set in which we have a string value categories. I will convert into a numerical form. Uh, I will use the feature selection and retention techniques, remove redundant or highly correlated feature to improve the efficiency using heat map or correlation matrix. I balance the data using smart techniques that will balance the phishing and illegitimate websites. And then I will split the data set in testing, training, and validation sets. So I mostly divide it into 70-20-10 ratio. 70 is for training, 20 for testing, and 10 for validation. In deep learning, so I will group these features into three part. One is the related to HTML and JavaScript related. One is the security headers related. Another one is use URL based features. So in input layers, I will divide these URLs. So I apply LSTM and URLs features, CNN on hype, CNN vectorization applies on HTML and JavaScript feature, and encoding into a dense layer vector. I applied that layers into a security header features. I use more technique to balance the data and divide it into a training, testing, and validation sets. Compile a hybrid model and integrate with the shape technique to check which features have most influent and improve the model transparency. So let's show the result of my models. So first I will show the result of random forest. In this way, you can see the confusion matrix explain that's so highly positive, highly true positive, highly true negative. It means that if you pass a legitimate site, it will strongly detect that this website is legitimate, and if you pass a phishing website, it will strongly detect this is the phishing website. So minimal false rate of the prediction in random forest. So accuracy is 99.8%, precision and recall is 99.7%. So in the learning curve of random forest model, you can see that it is smoothly and there is no overfitting uh, apply on that models. So let's move to the decision tree. It's same like a decision a random forest, but the false ratio is slightly higher than the random forest. And learning curve also explain that this model is learning smoothly, and there is mild overfitting less robust than the random forest model. So let's move to the hybrid model. So this model is perform much better than the existing two machine learning model because I propose methodology using a shape technique. Only relevant and most effective features passed into a model. On the basis of that, train and make a result. So you can see There is accuracy of 99.9% with strong precision and recall. So let's move to the data analysis part. As I showed you, I have a legitimate sites of 1,34,850 URLs and 1,945 9,000 1,945 are phishing website URLs. So this is the heat map correlation matrix that explain the which feature impact most and which feature is not impacting most on my target class, that is detecting label class, that is detecting which site is phishing or not. So this is the shape technique I apply on HTML features. So as you can see, it's explain that which features impact on our data set, our target class, and this is the security header rated features that explain that is the which feature impact on which feature is most impactful on my target class. So let's move to a demo. Before moving to a demo, I will split this demo into three parts. One is the data analysis part, that is visualizing impact of the data and model training. There is two files. One is for machine learning model and another one of the deep learning model. And then I will show you that model integrate with the website on the to predict website URL. I use tools and technique like PyCharm, Kaggle, scikit-learn, NumPy. These are the libraries Python that is used in this uh, research. So let's move to the data analysis part. So in this URL, in this Kaggle file, you can see that I will load the data and perform some cleaning on it. It shows that we have 83 columns and 35,795 records. And legitimate, this is the comparisons of the legitimate and phishing websites. And as you can see, if I pass a domain like 10.95, these are the digit domains. So all the domain have a phishing website according to our data set, but the legitimate site don't have a domain ID, IP. So here is explanation of all the data sets. So this is the features like number of Python empty references, number of self references. These are the feature that is related to a web's HTML rated. So I show that which feature is most impactful on phishing and which feature is most impactful on uh, legitimate websites. So this is data analysis part. Let's move to the model training part. First of all, I will show you a hybrid model. I install the necessary Python library that is not available in Kaggle, and then import the libraries, perform some pre-processing on it, cleaning, and divide into a three parts. One is URL features, another one in the HTML JavaScript related feature, and last one is security related features. So split the dataset in training and testing and validation. Apply LSTM on URL features. So as you can see in the URL related feature, URL input, I will apply the LSTM, apply CNN on HTML and JavaScript related feature, and then I will compile this model and give a summary. And here is the model training. And lastly, this is the shape apply on all these three group of features. And lastly, here is the results, confusion matrix, recall, and all these things. So let's move to the machine learning model. So in machine learning model, we have some load the data sets, some perform processing and cleaning on it, then use the feature engineering part like encoding, label encoding, these techniques to convert categorical data into a numeric form. Also apply correlation matrix. And lastly, I will show you where is the model trend. Here is the correlation matrix, and yeah, I use the random first types classifier with these parameters, hyperparameters, and here is confusion matrix. And this is the classification report, and the second model is decision tree. So it's the confusion matrix of decision tree and classification reports. So let's move to the websites demo. First of all, I log in. Before login, I will not use it. I make account. So as you can see, model results, phishing website. I passed two URL. One is a legitimate site. It will show you the its website is legitimate and all these features with value. And lastly, I pass some uh, hybrid, phishing website. So it shows that this website is phishing URLs, and these are the features value. So dataset features, this is the extended feature that show that in phishing website and which feature is involved in phishing website and which feature is for and legitimate sites. So this is the correlation matrix. And this is the analysis part, that is graph I show you. And this is the form that show the phishing website and types and group members, etc. Uh, that's all from my side. Thank you so much.